Good morning, my wonderful friends. Roger at Mud Fossil University talking about fossils and the bones of dinosaurs. And what we're looking at here is a channel called Is Genesis History? The Bible. Is the Bible telling the truth about our history, or is it just all nonsense? Well, let's examine the evidence and then we'll make a determination. What he's looking for here is bones. Well, I'm going to tell you something right now. I discovered a process. Bones do not survive from the Great Flood. And here's what happens to bones. This is a goose head. Now, there's bones in a goose, but there's no bones in this one. And the reason is it's called nucleophilic invasion. You see this? This is where the feathers were. All right, there's the feather pattern. That's the goose. That's his beak. None of that stuff has survived. Not the bones, not the flesh, not the skin, not the feathers. It all turns to stone. And why does it do that, Roger? Well, it's called nucleophilic invasion. What happens is the fleshy material and the biological material in bodies, when they are submerged in salty waters about the same saltiness as in us, about 7.35 pH, it preserves everything underneath the tissue layers, the skin, the fascia, feathers, all of that survives, but bones specifically do not, because they are way over here in the left side of the periodic chart. They get invaded by all of these nucleophilic particles. They have extra electrons. They invade this because it wants electrons. When you're alive, nothing is stable. When you die, either you get stable or you rot. Well, to get stable in watery, salty waters, these electrophiles have a lot of electrons, invade these nucleophiles and become different molecules than they were when they were alive. But they maintain 100% of their anatomy. And I mean 100%. They are identical to when they were alive. And I can prove this, and I have so much of this stuff, it's just phenomenal. And my stuff is DNA certified, and my stuff points exactly to what they said in the Bible, giants. Okay, that is a giant thumb from a giant human. And I'm not kidding you, it's giant human because I have the DNA test to prove it. And I will show you those uno momento, because there was 3 things done. This was the giant biggest one. And any anatomist will fully understand that is the pad that is on the back of the thumb that bumps up against the next bone so that you can do this. This is where the tendons come up the side so that your fingers can do all these movements. This is the fingernail. That's literally the fingernail. And this is in such good condition that the fingerprints are absolutely flawless. And here's the fingerprints. They call it grip skin. You see this? This is what grip skin is. It's fingerprints. This is what fingerprints are. Fingerprints. That's what they are. Now, these are the sweat pores. This was, I broke it off the other side, obviously from the other side of the fingertip to get these fingerprints. And I drilled up inside of that fingertip in an arterial area, which means you've got red blood. It's hematite, not the magnetite, hematite. And it's almost powdery. It comes out in, you just drill it out, it's like particles. But the particles hydrate very easily and become back into blood almost, and sometimes totally blood. Let me show you well, here. This is another one I had tested. This is a lung. It's a human lung, and it is human. Again, I drilled up in here, a little pin drill, took out the same stuff like I took out of the artery up inside the fingertip, sent it off to have that tested, and it was also human. Now, and I also did one other one, which is another giant hand, smaller than this, but still giant. This is gigantic. The fingertip itself is 3 feet long, just the tip of the finger. Now I have another one that the hand is 3 feet wide. But still, a hand, a 3-foot wide hand, is not too bad. Here's the hand. Hold on one second. Pictures. All right, here's the hand. All right. If you take your own hand, your left hand, put it out like this, and lay it back, there's your pad of your hand around here, and then it runs right down the side, just like this, just like your hand. And then there's another thing that runs down this way, which is a little tendon. It's exactly like your hand, because it's a hand, and it is human. It was DNA certified. And this is the grip skin. Remember I just showed you the grip skin a minute ago? That's the grip skin. It's on all of your feet and your hands and your fingertips and so forth. It's very, very tough. And you see it's silvery looking? That's because this has different chemistry than the pad of your hand and the rest of your body. This is really tough stuff. And this is where I believe the iridium came from, in the iridium layer that they said was from an asteroid. It is not from an asteroid. It is from the grip skin of giant, or of all creatures, have the same stuff in them. Now, you have dense silica, and you have, I believe, iridium. This can be tested. There's no question. I can't do it, but somebody could do it. And if there was found iridium was heavier in this grip skin, that would account for the iridium layer that they found, Alvarez found on the whole world. He says, well, this had to be a gigantic asteroid because the whole world is covered with this iridium, and iridium only comes from asteroids. No, it doesn't. It comes from biology, and biology of the grip skin is where it came from. If somebody would test this stuff, you know, if somebody wants to make a point of saying I'm wrong or wants to prove I'm right, either way, I don't care, because one way or the other it's going to come out. Is this right or is this wrong? I say it's right. Now I just showed you that lung. I have another one here that's the pleura, which is the coating, the wrapping of the lung, has disintegrated away. They come in all different states of decay, and even come down to this one. That's a lung too. That's a lung too. But this was in a different chemistry. So here we have one that almost is not deteriorated at all. That's almost transplantable. This one here is, all of that stuff is gone, and we're down to the alveoli, and I can show you the actual alveoli. You see these particles? This is the same stuff. It's right there. Those are the alveoli. And what happened to them, there was blood dense in there, and it ran out over on my counter. This one, it was in a condition where there must have been a little extra salts or acids, whatever, but it ate out all the blood and the tissue that covered the surface all the way down into the holes, and turn them into holes. You see it? It's another lung. Now, this is the stuff that guy was looking for, is bones. Well, that's a bone. I guarantee you that's a bone. And there is actually the tiniest little taste of bone right there. If in a microscope I can find it. But this is, again, nucleophilic invasion. This was in salty waters, and I did it myself. I've made my own mud fossils, and they come out just like this. Same thing. They look just like a piece of rock or dirt. And it took about less than a year or so to do it. And but you have to have the same. You got to have the right pH. And you have to have them continuously. You have to change the water and so forth to move around, and you have to have a lot of blood in the water too. You have to. I use blood meal. I think I can't remember. This goes back 6, 7, 8 years ago, and I think I used blood meal. Well, I use sand and blood meal and bone meal and you know, salty waters. I got it into that 7.35 condition, which would, all of the things I'm talking about I put in the water is all of what's going to be in the water, because everything's saturated and it's leaking all of its fluids into the water. So this was able to suck up the correct transitions. These are transition metal complexes. This is what moves chemistry through a body. When you die, it doesn't move anymore. So these have to find the correct ones to bond to create stability. And that's what we're seeing all over the earth, is stability of rocks that were from creatures that were drowned. And the creatures that I have here are on the surface of the earth. They weren't, I didn't dig for them. You know, some of them a little bit digging, but not much. So you can find these all over the surface of the earth. You don't have to go digging around. And I said within 15 minutes you can find them. No question whatsoever. Anywhere you are on the face of the planet, basically. There's going to be areas that won't have a lot of mud fossils because there's been sedimentation and so forth. But it's not sedimentation. It's not the things that they're looking at where they're looking at layering and saying, oh, that's sedimentation. No, it isn't. That is layers of tissue. Okay, so this is Dr. Arthur Chadwick, and seems a nice guy, and he's thinking, and I like that. But they never ever expected these giants to be as huge as they are. And they never ever understood nucleophilic invasion was the process that led things to become stone. Even though you would expect to see bones and so forth in here, you're never going to see that because, as I explained, nucleophilic invasion. That's a bone, but it's completely preserved as a bone. However, it's now become stabilized by invasion of nucleophiles. That's nucleophilic invasion. All right. There's stuff that has a whole lot of extra electrons and stuff that wants electrons. When they click together, they stabilize. And in these kind of watery conditions, that's what happens. I hope I explained that sufficiently. Now, let's listen to what he says. He says, how do you preserve a fossil? Now, let's go a few minutes here. Here goes. Here goes.
What kinds of processes are involved in fossil preservation?
Art, it's obvious that what you are doing there at the Hansen Ranch is digging in a huge mortuary. I mean, it's a huge deathbed.
And that's what taphonomy is about. Taphonomy is the science of finding out what happens to an animal from the time it's alive until it's excavated. So it includes the cause of death, what happened after it died, did it lie around and decay, or did it get buried quickly? And the evidence that it got buried quickly is the preservation of the integrity of the organism. Now, in the case of these dinosaurs, their original death was followed by a period of time during which we assume they were scavenged and where they were rotting.
I agree with that 100%.
And then after they were pretty much rotted, maybe a few days.
And what I want to point out is mud fossils never get to be rotted because they are always underwater. When you're in the water, in the same salty conditions, the same blood and all the stuff that is in these organisms is going to be in that water. And when it is, that organism says, hey, I'm not going to rot. I'm not going to go away. I'm just going to try to find a way to get stable because I have so many different molecules passing by me all the time that I'm familiar with because they're all body minerals, and I can hook up with one and get stable, and that's what they do. They hook up and become stable, and then I get them out of the ground and or off the top of the ground, and I drill deep inside of them to get actual blood. And let me show you just to be sure. You see that? That's a bone. Let me show you before we go any further. All right. Any anatomist in the world understands that is a bone, and that's a kind of a bone attaches to another one and has a ligament between them, so they're locked together, but they can sort of do this kind of stuff. Now, there's additional what they call bone foramen, which let blood and nerves function between bones so that you can connect them. Now, when this broke in the mud fossil condition, when I took it out of the mud, it bled. Literally bled, and that is blood, no question whatsoever. And that is a bone, no question whatsoever. And this is the scab fibrin, which is the clotting fiber that allows the blood cells to collect in there. And I have tons of this stuff. And I can in the bone foramen, you're going to see the holes that are these two holes here. That one there is the vein, and see this black stuff right here? That's the vein blood. It's called magnetite. This is the red blood over here. You see the reddish looking blood? That's the artery blood, and that's the hematite. This is the hematite they want to make iron from. Magnetite is a different story. It's less oxygen in it. But anyway, that's that bone foramen. Okay, let's continue on here. Now, he's saying what caused all your dinosaurs to go extinct, and now he said he mentioned the asteroid. Let's see what he has to say.
But now let's talk about from a Genesis paradigm. How do we explain that?
When we look at the fossil record of dinosaurs, we find that they are killed off in layers. Also, we have the Triassic kinds of dinosaurs here, and then we have the Jurassic kind of dinosaurs higher up, and then we have the Cretaceous kind of dinosaurs at the very top, and right at the very top we find Tyrannosaurus rex and these duck-billed dinosaurs and the kind of things we're studying in Wyoming, because we're just right below that layer which ends the Cretaceous. And so I think this process of burial.
I just want to mention, let's go back again and see what he said about that, because this is very important. It's right at the end of the Cretaceous, right in that area. Now listen to what he has to say. Also, we have the Triassic kinds. Now he's talking about the different types of dinosaurs, and they are going to die off in different sizes probably because of the flood. The bigger ones will probably last a little longer than the little ones. I'm not sure, or it could go either way. But listen to this now. So they have different types of dinosaurs dying off in different stages.
We have the Triassic kinds of dinosaurs here, and then we have the Jurassic kind of dinosaurs higher up, and then we have the Cretaceous kind of dinosaurs at the very top.
Do you know what Cretaceous means? It means the mud. Now you see this? Cretaceous, resembling or containing chalk, which is mud. All right, so let's go through this again, because this is ultra important. You understand the stages of the die-off and then the mud. Mud is nothing more than decayed flesh. Flesh is the weak part of the muscly tissue. A lot of it eroded. Yes, a ton of it eroded. Most of the tendon did not. Listen again.
Fossil record of dinosaurs, we find that they are killed off in layers. Also, we have the Triassic kinds of dinosaurs here, and then we have the Jurassic kind of dinosaurs higher up, and then we have the Cretaceous kind of dinosaurs at the very top, and right at the very top we find Tyrannosaurus rex. And
all right, Tyrannosaurus rex would have been eating all these other kind of dinosaurs probably, so it lived to the, maybe eating them out of the water or doing whatever he could to survive. But at some point, most of the creatures died, not all of them. It was not a biblical extinction like they say, and everything died. No, that I don't believe. Well, I know it's not true because I have all kinds of stuff that shows that it's. Well, I'd have to have somebody show me, forget that line of talking, but I have all kinds of things that show that this thing survived the flood, and there was actually advanced creatures here doing something with the body parts that were left over after the flood. Let me show you that now. All right, they're talking about Genesis from a biblical point of view. The other guy's talking about Genesis, just a natural evolution of things. And I'm talking about, well, what the hell is this going on here? This is from that time. And they had machines here, and they cut these slabs. And this is wet tendon flesh. When they cut it, it was wet, obviously wet, because they're sunk into it. And they had a vehicle designed to work this specific type of terrain. And then they cut these slabs and made walls out of them. I have so much details on this, and I have every bit of the anatomy, the chemistry, the whole 9 yards, and we missed virtually everything. They've been looking in all the wrong places. Let's look through this whole thing, or it's meaningless at this point. All right, I don't mean to keep cutting in and out of this, but it's important for you to understand
these duck-billed dinosaurs
what's going on
and the kind of things we're studying in Wyoming, because we're just right below that layer which ends the Cretaceous.
The end of the Cretaceous. That's the end of the mud. The mud finally subsided and dried up, and all of the creatures that were on that mud, which is the eroded flesh, turned into these kind of things. Rocks, because they were already nucleophilically invaded. Once they dried out, the H2O, water gets out of them, they turn into solid stone. Now, you could see the neck and everything in there if you look at it in the right light and everything, but you're never going to see the kind of things he's looking for. So, wait till you see what I'm going to show you in a minute. All of this is gigantic creatures that were so gigantic, And we're going to return to him about Genesis, because Jesus said the earth is a body and the earth is a corpse. I'll show you that.
And so I think this process of burial couldn't just be explained by a single asteroid. It has to involve something, dare I say, much bigger than that, and certainly on a grander scale that encompasses the whole Earth.
I agree.
And we find evidence for this in the direction of currents that are
This I will not agree with, and I will show you why.
flowing over the surface of the Earth. For example, in the rocks, if you've ever seen cross-bedded sandstone,
This is not cross-bedded sandstone. This is biological tissue. I'm going to show you, I have it here, the same exact stuff, and this can be tested too, right now for DNA, because DNA has changed the whole. I was the first one in the world to have DNA done on giant human beings, and now it's being done regularly, but they still won't think about this. Mine were human, 100% human. Okay, you remember he's talking about cross-bedded sandstone back here. This is exactly what he's talking about, only this is not a sandstone. Well, it is now, but originally it was a shoulder or a knee or something. Any anatomist will understand what that is. That was whatever the bone that it was attached to, and there's the center of it, and this is the glue. Literally, it's like glue that glues a little piece of tendon into the muscle. The muscle weaves into the tendon, and then you have the muscle fibers and all of the cross-bedded stuff that he's talking about, and all of the. I mean, this is what it is. It's not. His eyes can't open up big enough yet. We're going to open them up, I hope. You know, because if he's honest and he wants to see the facts, these are the facts. All right, look, I can go right from his into mine. You can't hardly tell the difference. It's too hard to see. I mean, it's what it is what it is. And no, there's not an anatomist on the face of the planet would straight face say to you, "Oh, that's just a rock. It was never any anatomy there." And I know that for a fact because I work with the top anatomists in the world, and they say, I cannot say what it is. I can say it has the anatomy of a shoulder or a knee, or because I have all this stuff. I have lungs, and I mean, I think I've shown you all these things. That's an apical tuft. Only a very top qualified anatomist will understand what that is. That's the tip of a finger, and that's the tendon balls that lock into these little holes at the tip of a distal phalanges finger. And I have worked on, not a single one of them has ever disputed one word of what I have said. They say it's spectacular, yes. And this right here, I don't know if you can see that up there, that brown spot, that's blood. That's blood coming out of there. That's not just eroded sandstone. Okay, we're back again. Now listen to this.
And the sandstone that lies at an angle like this, that sandstone tells us which direction the current was moving that deposited that sand.
Now, he's saying, oh, it must have been going this way, and then it went this way, and then it went a swash way. These are layers of tissue. Even though they're gigantic, they are layers of tissue, and I'm going to show you. These are the same sort of things we just saw. The reason you're seeing these different colors now, instead of just the mud, which I showed you in mine, and the one that he showed before, that just sandstone, which is, it's a different chemistry in that water. This was near probably, it could have been a heart or a kidney or a liver or bile or whatever. But there'll be, you have to understand chemistry. You have to understand these are the transition metals. And you have to understand nucleophilic invasion and substitution. And what happens is the molecules that are normally given and taken to be alive, they have to give and take. They're not just static in your body. They're always given and taken. Oxygen, glucose, all of the different minerals and metals. And it does it with these. When you die, these move over this way, these move over this way, and they stabilize in the middle using these transition metals, if they're available. If not, you will always, the ones I have, a lot of them are just literally look like mud. But that's because of the condition it was in and the chemistry of that particular watery area. And they were all in different watery areas. And because they were in different locations near, the intestines, near the lungs, near the kidney, heart, all of those have different transition metals. And especially your heart, anywhere we have blood. This is blood. That right there is blood. That is blood. Blood. And this right here is blood as well. And what is blood? Blood is the transition metals. You see this? Titanium, vanadium, chromium, iron, all of that stuff it can transition. That's why they call them transition metals. They go back and forth giving and taking electrons. They move products through the body. These are what ends up stabilizing other things that want this number of electrons to become stable. If they can find somebody that will give them that many electrons, they won't rot. Simple as that. And because they're in this aqueous solution with a lot of pH, well, a little higher pH there, so that it moves electrons easier when you're in this range here, higher electrons in the water. So they're going through, and one guy will say, "Ooh, I need you, I need you." Let me show you a heart. Where do you see this? All right, once again, any anatomist in the world, anybody with a half a brain can see that was a heart. Now, it's opal now. Well, what would cause the damn thing to turn into opal? What's the story with opal? Well, opal is in a very special situation where the waters were extremely clear and extremely dense with blood. And this, of course, is dense with blood anyway. But it's the water needs to be able to move these molecules and have these heartstrings and these ventricle walls and so forth find the molecules that they want. Now, they won't always find exactly what they want, but they'll find something to bond with. And how can I say that, be certain? Well, you see this blue color here? That's the ventricle wall. This is a ventricle wall too. It's not the same. It's yellow. It's green and blue. And it's a darker blue and a green. And apparently, using these two substitutions, you can make up for what that would be. Now, in my mud fossils, this would actually turn into mud. I got lots of them that are just solid mud. I have some of them that are solid glass. Well, here. That's a heart. And what happened to this one, it was in a condition where everything worked out of it. It must have been in some really, really caustic condition where all the molecules that were biological left. And then, because this is, I believe this is a heart or a lung, I could be wrong, but I would go with a heart personally. And these are all the areas in the heart that normally would have had blood and been tissue and so forth. It's been completely replaced with silicates, right? Silicate, like glass. Now, this is it's a heart. There's no question about it. And you see all those different transition color metals in blood. That's why I say blood is transition metals. Those were the same metals that I just showed you, iron and all these different ones. And that blood, this thing died and was invaded by those colored transition metals to stabilize. That's what opals are. They're transition metal invaded biology, and every one of them is biological. I was looking at you, sweetheart. That's an eyeball, and that's the strap of the eye. You see all these different transition colors? Your body is completely different in every little area, and when it is, it takes on a certain color. It's just the nature of biology. You see this yellow, you see this dark, you see this green. That didn't just happen by accident. It happened because it was able to acquire the exact molecule, molecules or atoms, to stabilize itself from its original biological material. And this, you needed some yellow transition metal to come in and say, okay, if you hold on to me, I hold on to you, nobody will hurt us. Say, okay, hug me up. And they hug together and they stay for like that forever. All right, he's talking about the only reasonable way to produce this is...
To produce this is to have processes that are not going on the Earth today. When you look at the rocks themselves, you don't see evidence for the passage of a lot of time.
There is no passage of a lot of time. That is a creature that died, and that is the size of its body. I'm going to show you membranes. There are thousands and thousands and thousands of membranes in that thick of a piece of your body. These membranes are absolutely phenomenally gigantic. Tyson Carlson is out on the West Coast. He has a site. I'm going to show you the membranes that he has from them. And the membranes in us, like I say, there's thousands and thousands of them in a very small distance in your body. And they are loaded with bacteria that saves you. Membranes are your defensive system. And they had them too. And these creatures, they were 6 feet thick, some of them. I'll show you. You know, when I said there's thousands and thousands of tendons, of membranes in a certain distance, there's thousands and thousands of fascia fibers. Well, the fibers are separated with fascia. Fascia is virtually, to me, the same as a membrane, although they call them synovial sheaths and so forth. But they separate one layer from the other. Everything is separated from everything else. And this is a tendon, and you get down to this size here. Giant's Causeway is tendon fibrils, collagen fibrils. They could test this stuff now. All of that stuff out there, I've looked at it. Well, I haven't been there myself, but I've looked at everything I can online. I don't go too many places. But it's not hard to understand if you understand, and I understand. Oh, you see this? That's a tendon ball with a strap. They're all over the place, and he's standing there taking pictures of this. You can see his shadow. These are much bigger than a basketball. The balls and the straps that he was just looking at are these right here, and that is in this mucosal area, which is your membranes that protect you from invasion. And I get into that pretty deep too. Once you start learning the chemistry of the body and how you protect yourselves, and mucosa and serosa that are produced within these bags of fluids protect you. And the tendon balls are the tough spots, and the straps still remain. And all of that erodes away, and it turned into clay. You just saw it. It's clay all around it. And where do you see this one? Don't forget. Remember this. Remember, you have a mucosal lining or skin or whatever, and below you have the interstitium, and embedded all in through it is these balls and these straps. So if you had an ocean going up against a gigantic creature, say it was 10 miles high, it would erode this, and you would see these balls laying down at the bottom because they're tough. You saw how tough they were in Tyson's shot. And you would see like a clay, and with all the balls still in it. Let's see if we can find anything like that. And it appears to be on this particular place in Norfolk, we have exactly that. There's that layer at the top. All the balls have eroded and fell down. This is the interstitium layer, and there's still all the balls, and they're still falling down and eroding down. This is what we live on, and it's time to understand this. And if you look at the Gnostic text, it says that the earth is a body and the earth is a creature. And if you look it up in the Gnostic Nag Hammadi, I think it's numbers 80 and 56. That's what it is. 80 and 56 say earth is a creature, is a body, and earth is a carcass. I can't see any situation that contradicts that. And don't forget, we talked about the mud. This is the mud. That's the layer of mud that's just eroded from the gooey flesh. Let me show you one of Tyson's membranes. The membrane itself is 6 feet thick. All right, again, this is Tyson's, and he's got a site out there. He's got a drone. He's been doing fabulous work. The membrane here, this particular spot right here, all that is down here. You see these little membrane channels? That's that. You see this like here? This little thing right here? That's one of these. This is the lower layer only. This is what they call an aqueous bilipid layer, which keeps it separated, and it also holds those bags of fluids in them. Now that's all gone. eroded away. And up above, 6 feet above, is this layer at the top. And it's just what it is. It's time to take a whole new look at things. Now, if they're honestly looking for reality, and even like closer to truth on public broadcast system, I'm trying to get a hold of everybody to try to get this understood. Because right now, you can make all of these assumptions about things, layering, sandstone, this and that. And let me show you Muscle Mountain, and then I'll probably wrap it up. And I'm hoping for some responses to this. And I need some exposure on this because I have the evidence. I've been doing this 10 years. I have more evidence than anyone in the world right now. And I have more informants that are telling me things all over the world and showing me things like Tyson, like Greg Morrison. I mean, I got them all over. I don't want to miss anybody's name, but these are the two of my top guys. And it's until we look at this in the light of Genesis, in the light of chemistry, in the light of history, we're just making guesses on things that are not supported any longer. All right, I showed you this rock I have in my shop. This is the blood. This is the muscle. This is these interwoven things that they're talking about. These are the bundles of muscle fibers, and they break at certain places called abrupt transitions. This is the tendon area. This is the glue in behind. And back over here, I cut that part off, which is that bone wherever this was locked into, because every muscle and every tendon is locked into some bone or somewhere in your body, and it pulls against these with little muscle fibers called sarcomeres, and those sarcomeres are little blocks, they're little bundles, and they break in these bundles, and you have to have blood to support all of this activity. Now, this is exactly the same as Muscle Mountain. Let me show you Muscle Mountain here. Hold on. There it is right there. So, you know, until somebody looks at this with a really open mind, and you don't have to be too open-minded to understand what you see. All you have to do is be realistic and engage. I have the evidence. Well, let me show you my DNA reports. I showed you the giants I have. Here's the DNA reports. Okay, I showed you the big finger, big hand, and a big fingertip, and the fingerprints. And this is a fingertip that came off of the palm that I showed you. Well, I guess it was a left hand. And, you know, that's the pads on the bottom and so forth. Apical tuft is out here. It's semi-eroded, but in the CAT scans, I had CAT scans, you could see the fingertip where the fingertip was, and I mean it is what it is, but this is a clay. I mean, this is turned mostly into mud. That's where the tendon's hooked in, and did this stuff. In the CAT scan you can see all the blood vessels and so forth, but other than that there's no other articulation to these things because they have been invaded and changed from the bony structures that you would normally see as a weak signal coming back. But that was the hand, this is the fingertip, this is the lung. Now, let's see the DNA reports. And because all three of them were on the same report. Let's go back out to here. Now, this was done by Helix Biolabs. Now, I want you to fully understand this. I extracted the samples from this lung, from a red blood down in here, and I extracted from the hand, from both of the fingers and the hand and so forth, from an arterial area. Now, the clay one, this one here, did not have as much DNA in it as the other two. This was dense with DNA. This was like, well, you're going to see excellent quality there, and the gigantic hand was excellent quality. So let's go through the report. Now, I was the one who extracted it. All they did was sample it and test it, doing PCR DNA analysis, which is very sophisticated. I believe that's about as high as you can get. Now, this was back in 2015, so this goes back 6 years. And these were the three of them, the 36-inch finger, that big long one. The lung is this thing I'm showing you here. And the mud tip was the other fingertip, and that hand. Now, they did all of this stuff. I have this online, And again, I was the one that extracted it. So if I contaminated it, well, prove it. I didn't contaminate it. Now, here's the 3 different samples and all of the different things of PCR doing this and that to it, and the positive and negatives and everything. Now, the 2 dense ones were dense, and the other one wasn't as dense. That's what I'm taking, because down here it says, and I did talk to Tom, who was the lab director there, and he said, yes, the 2 of them were absolutely unbelievably good quality, excellent quality DNA sequence obtained for the 36-inch tip, that's a gigantic finger, and the lung. And here was the results: Homo sapien, mitochondrial, cytochrome B gene, and D-loop region. Now, and this was from every DNA sequence that exists. They call it a blast. And it matched up 100% with modern human DNA. And they're just gigantic, absolutely gigantic. So what does that tell you? I don't know. But this was a very sophisticated test. So I am not making false claims and just saying things that have no support. And as far as I can tell, there doesn't seem to be much interest in the reality of what we actually came from and what our past is. Because I've tried, it's 10 years now. I'm not a quiet guy. So I'm hoping this time someone will stand up and take some kind of do something about this. I mean, I see so much that relates to so little, and I see so much that relates to so much, and just avoid it. So let's see if we can get this straightened out. But I need your help. Nobody seems, I can't seem to get through to anybody anymore. I've been put on a lot of spam lists and all kinds of things. I just got put on a spam list just for posting about Devil's Tower on Facebook. All right, see, this is about Devil's Tower. And all I was doing is saying that Devil's Tower, this is the bloody area that fell off of the feet from the Devil's Tower. I go against their standards that I'm lying about something. And I know somebody reported me. I don't even know who it was, to be perfectly honest with you. Because they just can't stand this reality. And all you have to do, apparently, is to report somebody and they'll just kick you off. Especially when you're making claims like I'm making, but they're true. You see that right there? This is Devil's Tower. This is actually where there's some bloody areas, where some blood serves the tendon. It does, but not a lot. Not like in the fleshy areas. That's why these preserve so well. It's CaCO3, calcium carbonates, and the red blood is still there. Now, this is what's called a wrinkle zone. And the reason is tendons are under tension. When you break a tendon, it snaps and it goes dip, and it gives you a wrinkle zone. And this is Devil's Tower. And at the bottom of the foot, it wraps around, these tendons wrap around the ankle. It's just the way it works. You see it over there. You see it? Now, I posted about this and I got taken down. Now, that is the tower right there, Devil's Tower, and the stand up, and this red stuff is where the guy's body fell over. And let's see, this is the back. These are, you could see this is not volcanic. It's just insanity. And that is that wrinkle zone, and this is the one I got taken down for. I don't know why, this one. But here's the red flesh. That's not erosion and sedimentation. That is ribs and things. And that is from the guy standing up and he fell over backwards. And this just shows there he was, and boom. And things grow very well around fleshy red clays and things. But you could see all of this is from that body. Must have fallen over backwards this way. And his arms went out or something, I don't know. But it's what it is, and it's just very hard for people to accept it. Any anatomist is going to look at that and say, yep, that's the flare of the tendons that wraps around the Achilles heel in the bottom. And you see it coming down here and bumping up in the back, coming up back. this is the tendon wrapped around where the bone was. When you see these red spots, these growing little spots up there, that's where blood was. Blood is the stuff that grows. You see it growing here, growing here, growing here? That's where the little blood vessels were coming up. Well, hold on one second. This is going to be cool. Hold on. We have new species too. This is a no-toe. You see the toes are missing? Well, they were inside here. And now it's all turned to sandstone, yes. Well, guess what? That's where the bone was in the back, and that's why it's growing just like it's growing there. It looks for red blood. And the moss and, well, primarily, well, look at this. You see here? You see that round spot? I hope you can see that. You see that? That was a bone. That's where bones were coming in. And these are not the same as our feet. We have a whole lot of these. And but that's where the reason I was showing you this is because that's where the moss is growing up. But here, let me show you another one. This is a foot. Now, it's a foot like we have, only the toes are built in. This is not a shoe. This is the tibia one here, which is the big bone. And the little bone is the fibia that comes up the side, so you have two bones coming down. This one just lays and falls off the side, and I have a lot of these in there. Now, when they made these, somebody created these because there's springs inside here instead of tendons. We have tendons that come out and they pull back and forth and do all these things. These have springs. They load, and there's two springs. One loads up and another one loads up. So again, I don't know. This breaks everybody's paradigm, and I'm sorry, and I always keep saying it, I'm sorry I have to hurt your brain, but it's going to hurt your brain. I can't help it. If you want truth, you got to step forward and say, let's look at this. If you don't want truth, walk around in circles.